everybody. This is the Open Research Institute's FPGA Meetup. This is the 17th of February, 2026. And what we do at this meeting is we talk about what we have done, what we plan on doing, if we have any roadblocks, anything getting in our way, and if there's anything that Open Research Institute can provide in terms of resources so that you can get your open source digital radio work done. So we're going to start off with any updates from Aaron about OpenCPI work. So the floor is yours, sir.
Thank you, Michelle. So this week, this last week, I wanted to make sure that I had the right kernel modules available to me in the platform. Right now it's ZC 104, so it's Arch 64, it's a 64-bit ARM on the Sync Ultra scale. And I confirm it is built into the kernel that I'm using, because I had previously used the ton kernel module, ton.ko, to get to emulate a network interface in software. So it's available, and then I wrote a small application that utilizes it, and so created a virtual network interface, and I was able to send ICMP packets, so ping packets to it, and from within my C++ application, I could see the traffic being captured into the buffers. So the next thing I'm going to do is start working on integrating that into feeding the encoder. So when it's not receiving packets, it will do the padding that it currently does. But then when it does receive some packets, it's going to inject those into the encoder. So that's what I'll be working on this week. And so hopefully next week I can say that we have IP traffic down the DVB-S2 encoder. So that's my update this week.
Wow. Okay, that's a lot. Can you tell us, if you know, what the major differences between the ZCU 104 and the ZCU 102 are? Because we have a ZCU 102 in the lab, but I've looked at the ZCU 104 before, but we don't have one. So what I'd like to do is to make sure that we know the differences.
Well, I have that too. So the difference, okay. The work that I'm doing on the 104 will automatically correlate to the 102. I can switch now, so I guess I can do that. It just so happened to be on my bench that I didn't pull out the two.
Yeah, no problem. As long as there's not anything that would be difficult to port back and forth, because I know that.
No, the only thing that would different is that at build time.
No, the exact.
Yeah. I think it's a different part. I don't remember off the top. The 104 has the video encoder in it, I think, surprisingly. Or I'm thinking about the 106. But anyhow, yeah, it's just at build time in OpenCPI, instead of the 104, I just put 102, and it'll build everything for the 102. So, yeah.
All right, then I will not worry.
Yeah, that as soon as I think that's my plan is, as soon as I get this working on the 104, I can test it on the 102, but trying to get that on the lab. You guys, everything that you need to run it in the lab would be the next step after that.
Cool. Okay. That sounds awesome. Thank you so much. This is really good progress, and we really, really appreciate all of this. It's dynamic and interesting and innovative and very cool. So if anybody is listening to this and wanting to know more, then please go to opencpi.org to find out about this framework. Because this is a high-level magic item. This is good stuff. So thank you.
Thank you.
Awesome. Okay, so the next item is Opulent Voice. The protocol, the implementation updates, hardware and software modem work, anything for interlocutor, and the symbol lock work.
I can go. I don't have a lot of updates for this week, but fixed a couple of bugs related to the new AXI clock domain crossing that Paul identified yesterday. So hopefully those are resolved. He's still not seeing the uh, power readback working, but I am in simulation, so that's still something to understand why that's happening. I haven't just had an idea. I'm guessing that it's not the readback that's the problem. I'm guessing it's probably the power isn't being computed correctly, since the readbacks are working fine. We haven't seen readbacks not working anywhere else. So I'll just double check the RTL for the power block and see if there's something there that um, maybe there's that configuration or something. So, and then otherwise, I still I want to move forward with the second lock detect mechanism and then update the document accordingly. And then probably let's see if I may need some help to see how we might format it into something we could submit to QEX or IEEE or something.
Okay, very good. I think you're kind of underselling the progress that you've done over the past week on this, but
Doesn't feel like very much.
no,
Every little bit counts, I believe.
it does. No, it's significant work. So go ahead, Paul.
So if I remember correctly, last week we were testing acquisition time, and we were using um, the scenario where the transmitter is already on, and then you turn the receiver on, and it measures the time from when you turned it on, and it got all reset to when it has acquired the physical layer using Matthew's uh, physical layer lock detector, and that worked. And we found some numbers that were pretty encouraging, like less than a frame of time required. But that's not actually the critical acquisition parameter that measures joining a conversation already in progress, which is usually you don't care how long that takes because you're just wandering in whenever you're ready. What you're really interested in is how fast can you detect a new signal. And in particular, the most common case is when somebody just starts to talk right after squeezing push to talk, and you better be able to get acquisition during the preamble and be ready to detect a frame sync on the very first frame. That's also the common case for a short message and for any kind of asynchronous data that just pops out of nowhere. So I wanted to measure that, and I can only sort of measure that. But I figured that I could get pretty close to measuring that by just checking acquisition time where the transmitter is generating nothing but preambles. And that's relatively easy to do because we have some control over the preamble generator thanks to the registers. And what I originally thought I could do is turn on the force preamble bit, and then every time I tried to transmit, it would just put out preambles. That is, in fact, how it's supposed to work, but that wasn't working when I started trying this test. I think is that one of the things that's been fixed, Matthew, since or is that still outstanding? I can't remember.
It should be fixed.
I haven't had a chance to test it yet. Thank you. But I was able to generate preambles by turning on the automatic generation of preambles and then setting the length of the preamble to something ridiculously long. In particular, the maximum it can be set to is 6 Fs, FFFFF, which is about 5 minutes worth of preamble, which ought to be enough for anybody. So I did that, turned on the preamble, and was able to acquire it in a similar amount of time. So that's good. That suggests that we should be able to receive that first frame. It's also bad because it doesn't explain why we're not actually receiving that first frame. So that was a test that I hope would shed some light on that problem, and it didn't, but it did give me some constructive information. So this morning, or yesterday, I guess, it just seems like this morning, I decided to test another thing that Matthew had created, which is he put in clock domain crossing circuitry of his own instead of using the provided stuff. And one of the things we hoped is that would fix the reading back of power. And I haven't yet finished building the final version of that. I built a version that revealed some problems, 2 problems, and then Matthew provided me with a fix that fixed one of them. And then this morning when I was able to report that to him, he quickly turned around and version that fixes both. And I'm building that now. So maybe there'll be something interesting to report um, soon, or probably by next week's meeting, because I probably won't get a chance to work on it during this meeting. The hope is that it'll work just exactly like it did before, except maybe the power will start working. Yeah, but there may be some, as Matthew said, there may be some other reason for the power not to be right. Oh, the other thing I was working on this week was for the remote lab, general purpose remote lab work is to upgrade our remote desktop capability from regular VNC to RustDesk, which is apparently the new hotness for screen sharing. I set up a RustDesk server, which is just in charge of connecting to people who want to share desktops. It's running on Chonk, the machine that serves our virtual machines in San Diego. And that works. It seems to work. Getting the individual VMs set up to talk RustDesk is a little bit harder. In particular, the ones that we've used the most, the Choco Cat and Karapi, are running a pretty old version of Ubuntu by now. And they weren't exactly fresh when we started using them because we wanted to do something conservative. And now we're stuck on this old version. So we're going to have to probably upgrade those to a newer version to get RustDesk to really cooperate. RustDesk is supposed to be able to work back to version 16 or version 18, depending on which web page you read. But either way, we're version 18 on those old VMs, so we should be able to use RustDesk. Rick?
Are any of those machines headless? Or do they all have a monitor plugged in?
They have a virtual monitor
But they have
provided by
a hardware virtual monitor?
no, a virtual monitor provided by Unraid.
I'm having some difficulty with RustDesk on virtual monitors or no monitors on headless machines. They recommend just buying a $5 module and plugging it in to simulate a monitor. I haven't done that yet. I'm still working on the virtual monitor. So it may not be just a matter of updating. I'm just saying.
Well, and that's possible, but I do have an equally headless monitor running a newer version of Ubuntu that works just fine with RustDesk from a virtual machine.
Yes.
So,
understood.
um,
What version is that one? Was that the one you were using yesterday?
yeah, that's on Rhythm. Well, I just have a window in front of me. Let me ask it. LSB release -A, it says it's 22.04.5, which is an LTS release, codenamed Jammy.
Okay.
That's not the current version by any means. There, one LTS and a non-LTS version ahead of us now, but this is the last version that will run something or other that we cared about. Forget what. It's the recommended version for some stuff.
Okay. So it sounds like there's a somewhat complex continuum here with will it run headless? Does it have to have a monitor?
Yeah, plugging in a
does it have this
dongle is kind of
library?
a problem for a virtual machine. I mean,
Yeah.
it may not be impossible because I can allocate certain USB ports to a virtual machine as if it were owned hardware. So maybe I could plug a dongle into one of those and have it come up as a virtual monitor, but I, that would be just as dicey as not having a monitor, as far as I can tell.
Yeah, it might be for Rick's use case, that might be a pretty quick way to get it all to work.
Yeah, I do use one of those dongles in my home setup so that a headless Mac Mini, does screen sharing right. But as far as I'm concerned, it's just a workaround for a software limitation. I'd rather have software that actually works.
That would be great.
So that's been an interesting um, story arc of trying to get all this RustDesk stuff working. And I think that these two things that I'm working on simultaneously are interfering with each other to some extent because I've had to change the windowing system to roll it back from Wayland to X11 to get the RustDesk stuff to cooperate the way I want it to.
I forgot to mention that. That's the other thing. It doesn't like Wayland.
That doesn't surprise me. I mean, they say that Wayland is working on an experimental basis, but there's some things that it can't do yet.
So why is it the default when we load updated operating systems? I don't know.
Well, I think this weird
Well,
experiment.
Yeah, doing the Wayland works fine as long as you don't try to do anything too weird. And I guess remote desktop sharing counts as too weird.
So
People
what's
are,
the next step for this? Is it keep banging away at it, or like do you see a clear path through, or
I've not encountered anything that stops me from making progress forward. I wouldn't go so far as to say I saw a clear path all the way through. Um, I'm confident that it's possible because I can see it working on a newer version of Linux, of Ubuntu. Whether it's easy and worth the trouble or not remains to be seen.
okay, well, that's very interesting. And for anyone that's interested in this RustDesk thing, can you give a pointer to where people can learn more about it?
Well, yes, I can. It's rustdesk.com, I think. Maybe rustdesk.org. Let's see. If I type in rustdesk, yeah, .com.
Okay.
And it has a scary warning at the top because the most common scenario for hitting this web page is because some scammer has asked you to install the remote desktop so they can mess with your desktop.
Oh, wow.
So the first thing it tells you is, warning, you may be scammed.
Oh dear. Okay. Well,
No, that's not a great user experience, but I guess it's the reality of the internet.
okay, but this is a possible next step along in doing remote work, trying to deal with, securely accessing servers like we do, to run equipment, like Rick is really interested in. So this is a big contender. Like people are talking about it. This may be a step up.
Yeah, we've
Yeah,
already seen.
I've thrown away all my tools. I'm starting over. And so the keywords now are for me are Tailscale, RustDesk, Visual Studio Code, and Claude Code.
Yeah, I'm leaving out the last one for now.
Well,
But
I only put it in there, haven't actually tried it.
He didn't
yeah,
have any other
so
tools to throw away for that. So,
I see. We've already seen lots of reasons why RustDesk is better than VNC. It does a better job with scaling the windows. It's noticeably faster in a couple of important scenarios, and it's free. So well, VNC is free too, but it's uh it's good. And I think I missed a couple of other things that I've ever seen that RustDesk was better at. So once we get, oh, and it does sound.
oh yeah,
VNC
that's
does not do sound,
okay.
and it's better with cut and paste as well. So
Yeah.
this is all good. This will improve the quality of life for people who are using VMs through the GUI. My tendency, I do almost everything that I can through a plain text SSH session, but there's some things that just won't work that way, including the Vado tools that we need to be able to use interactively. So they require um, a GUI interface, and so a GUI interface will have one way or another.
Okay.
If RustDesk isn't the right solution, then we can always roll back to VNC. I've had to set up VNC in order to get RustDesk working too. So it's a double whammy.
Okay. No, thank you.
Having that forcing, I didn't get to the end of the story. That forcing me to roll back from Wayland to X11 means that I now have a system that was deployed by the developers of this release with the intention that it be Wayland. But I'm now running it with X11. It turns out there are lots of little X11 tools that don't get installed by default in that configuration. And I'm running into them one by one as I do different things, including, surprisingly enough, building our product. It pops up with every now and then there's a thing that I should have had because Ubuntu always has this because it's always X11, but not anymore. So
This is sort of analogous to assuming that you always have access to the internet when you design something. And then when you don't, then things get exposed in your design that you were depending on having like ambient internet. Is that sort of the same vibe?
It's sort of similar. This is a situation where they they dawdled and dawdled and dawdled because they were afraid to take the giant leap forward from X11 to something more modern. And so it took a long time for Wayland to get good enough to be used daily. And they finally pulled the plug on that and said, okay, let's switch everybody over to Wayland. They really expected that everybody would just switch over to Wayland. And but when everybody started doing that, and it became the default, then um, started to discover all the other things that Wayland wasn't supported by or doesn't support. And so we're in that transition period where the developers are ahead of some of the users anyway, doing stuff that's better in the future, but we're not quite into the future yet.
Wow. Okay. We live in interesting times.
Indeed.
Okay, but there's no impediments to what you want to do for like remote labs west, remote labs south, or any of the Opulent Voice support, LibreSDR support. Like there's nothing like messing your job up there. It's just
That's true. There are things that need to be done, like moving the older VMs up to something more modern, and probably some tearing down and rebuilding of the remote lab here, just to make it better, more maintainable, and work better in different ways. So they'll require some downtime and a bunch of my time, and possibly uh, these things can stretch on. It's hard to know how long they're going to take. Uh, Choosing the right time to do that is probably the hardest part.
Yeah, it's an art form. It's an art and a science. So, and we appreciate you because you have a competence here, and you have our confidence about moving forward on that. So, at your at your leisure, at your convenience, please go ahead and revise and upgrade the VMs and see what you can get going with RustDesk. That sounds promising, and I think we've seen enough advantage to know that it's the way to go.
Alrighty, I think that's my report.
Well, thank you. I have a brief Opulent Voice report from the side of the human radio interface or interlocutor. So this is what gives you the web interface or the command line interface. It turns your voice and your keyboard and your data into what we call baseband data frames or logical frames, and sends those frames in the correct order with the correct sort of prioritization off to the modem. And now we have two different implementations of the modem, a software and a hardware modem. And so we've proven that it works for both. And one of the sort of tests that I was really interested in doing was to make sure that interlocutor was resilient, that it would kind of stay up and not crash your browser or cause any problems. So I have a version of interlocutor running in a browser here that's been up for 57 days. And on a Linux box, it's a NUC or Nuke Linux box. Nothing special, fairly limited hardware, but it's been running and works. No memory leaks or weird behavior or crashes or browser lag or anything like that. So I think that's pretty good. Eventually, it will have to be shut down because there's improvements to interlocutor, and we have seen version skew has caused some weird duplicate bubbles in the UI. So when you get a text message, it has a little duplicate bubble just with the person's call sign in it. Not really sure where that's coming from. That'd be an interesting thing to track down. And it's missing like the slash commands that we've added, so I can't roll dice for you, sadly, because I have not touched it. I just wanted to make sure that we didn't have any problems like that. So from the beginning, we tried to make this to be very simple and straightforward. It is HTML5, CSS, JavaScript, nothing weird, nothing fancy, no weird frameworks or pulling in the latest and fanciest stuff. And I think it's paying off because the experience, you can have it up in a tab, plugging away. tracking traffic back and forth from either your modem or a connection to, in this case, a connection to a satellite simulator. So this is connected up to Locus, running on the Linode instance from ORI. So I think that's good news. I'm very happy to see that. That was the point of kind of having a restricted sort of restricted, that might not be the right word, but having a kind of a okay, we're going to use simple ordinary HTML5 and just keep it very basic, and I think it's paying off. So anyway, that's my report from my experiment here that's been going on for almost 60 days. I think I'll cut it off at 60 days and then refresh interlocutor because there's some things that we need to test and move forward there. All right. Any other Opulent Voice updates? Anything, any questions, concerns, or I think the one thing I know about that was not mentioned is hardware for an over-the-air test. Paul insists that we do this, complying with the regulations. And we need filters for that. And he wouldn't let me transmit sloppy stuff over the air. And so I now have accepted that as the reality. And so we're waiting on some filters. And Paul found some filters for both 900 megahertz band and also 70 centimeter band. And we're going to try to see how far we can get and what happens over the air. And that will be a good tests. So thank you, Paul, for asserting some discipline over the over the experiment. But yeah, anything you want to add about that?
Well, only that these filters are not necessarily chosen carefully. They're cheap, and they came up on AliExpress, and they look like they might work. They're cheap enough to buy and see if they work. If we wanted to choose a filter for the ages, it would probably be something a little more spec'd out, maybe something from a legitimate manufacturer like Mini Circuits or somebody like that. But that's going to be more expensive.
Yeah, and to add to that, the filtering that's available to us from the SDR itself. So from the platforms that we're using, I don't think we're completely taking full advantage of those filters. I think we have very basic ones, but there is some additional filtering on the transmit side available to us that we should do. We're already getting a lot of good filtering from, complex modulation and MSK itself. Minimum shift keying has some advantages here. So we're already seeing that in the spectrum analyzer, but we need to go the extra, well, it's not really an extra mile, but we need to do the right thing and to go ahead and make the transmit spectrum really clean. And so that's the whole point of the extra hardware.
Yeah, we're not talking about narrow filters that shape the spectrum. We're talking about low pass filters that knock off the third harmonic and the fifth harmonic and the seventh harmonic that
Right.
are not very well controlled by these SDR transmitters.
Right. We can see those. They're not as bad
Yeah.
as if this was another type of modulation or if we were doing real signals, but they're there and they're not okay. So,
And if we ran it through a power amplifier, which you'd need for any non-trivial distance transmission, they'd get worse.
right. So that anyway, that's in progress, and that's thank you for leading that. That's a sort of a components engineering challenge. And
So, sorry, are these modulation harmonics or carrier harmonics that you're speaking of?
Carrier harmonics.
Oh, okay. Wow. Okay.
yeah,
The modulations were very clean. That the SDRs have plenty of bits in their DACs to generate clean spectrum. It's the downstream radio stuff on the transmitter that's just not single band without some help from filters. They don't even claim to be. They don't try to be. Just like if you took an old-fashioned analog HF rig that didn't have band filters in it, it'd probably be illegal to turn it on.
Yeah, this is a common problem with software-defined radio. No filters, no nothing, to give you the maximum flexibility to do your design and your experiment. So the fact that we see decent results, not legal, but like not as terrible as other ways that we could do it, just kind of proves the theory behind what we're doing is right. But yeah, you still need to have transmit filters. You still need to suppress this stuff. Still need to be legal. And yeah, I was wanting to try it anyway, but Paul said no. So thank you, Paul, for
You can
for the
transmit with
idea.
your license whatever you want. My license, I'm gonna
I was
be a little more.
excited. I'm very excited to see this over the air. So I you know, I plead, I got the skis before the whatever, you know. Don't let your skis get in front of you on the, you know, if I've water skied exactly once and it ended as you would probably expect with lots of bruising. So, you know, don't let your skis get out from under you, but I did. So anyway, that's
Uh,
coming. Those things will arrive pretty soon.
I'm not as familiar on the UHF bands versus say 10 centimeters. Could you go up like to 10 centimeters and not have to worry as much from the harmonic problems, or is that just across the board for all bands?
Pretty much this is a problem with SDRs. This is just across the bands. Going to a different
I,
band won't help it much.
I mean, as far as the legal regulations for a clean signal,
Oh, yeah, I think we want to do it right. Since we want to, these are the bands we want to be
sure.
on, you know, we just need to do it. And to me, it needs to be on the air, separated, very different radios, different implementations as soon as possible so that you sort out all sorts of things and you prove, you know, have a essentially, you now you get a demo for free. So my
Yeah.
inclination is to get it out over the air as quickly as possible and to prove that it works. Um, but you know, the and filtering, amplification, correct configurations, all this other stuff kicks in almost immediately, and it's physics that is now in your way, not your imagination or a compiler or anything like that. And you don't get like the same if you run the transmitter and the receiver in the same system on the same radio with the loopback, you get a lot of things for free. You're not really testing synchronization, which is probably the most kind of central thing in digital communications. So all of that, we need to pull this stuff apart, get it working over the air, end to end as quickly as possible. And that pays off, even when it's painful and it causes you to feel like now you got to go outside of the lab and do something, you know, like why do I have to slog through catalogs for filter? Well, you do. So that's what we're doing right now.
So,
Yeah,
so people right now using a hack RF or a Pluto or something to transmit a signal, are they encountering this problem?
They would if they didn't have filters and amplifiers that were set up for that particular signal.
Really?
Yeah, all SDRs are kind of messy.
Hmm,
So it's just like
I
so it's
didn't
like
know
a
that.
well, it's like a it you will appreciate this because you know about control systems, basic control theory, you understand it. And
Yeah.
you know, so maneuverability comes at the cost of stability. And if you would like to have a very agile radio that does anything you want and you can reconfigure it, respin, you know, do broadband, narrowband, you know, adaptive, it's unstable. The instability for an SDR is because it's just messy. It's going to just splatter all over because the filters, unless you have an adaptive, reconfigurable filter system, then you're just not going to have that. They don't come with filters and they don't really put out a lot of power. So you have to amplify it. And if you slap just any old amplifier in front of it, you are not just amplifying the signal that you intended to make, but all of this other stuff totally unfiltered. So it's a bug and a feature all at once.
yeah, I would object to the use of splatter in that.
Sorry.
Well, splatter means something else and
It
very
does.
specific.
Right.
Yeah.
Overmodulation, right?
Yeah, usually.
Yeah. In
The
this
the one
case, it's like
thing
you're
that
modulating it on purpose, but you're also creating all of these other spectral components, which those exist. They
they're
exist
far
in
enough down though that you could, with a modulation like this, which is designed for reasonably tight spectral occupancy, that first uh, side lobe is far enough down to meet FCC as long as we don't regrow it with a power amplifier.
Yeah, and the other thing you have to be concerned with it would be like an IP3 intermodulation if you're driving your amplifier too hard.
Yeah.
True.
Hmm.
So having two independent implementations or two different implementations is a start. The perfect situation, which we can't quite get to yet, but we will get to, is where the other radio received nothing from you except a copy of the spec. You should be able to like mail them a paper copy of the air interface spec. They implement it completely independently and then talk to you successfully. That's the goal.
Yeah,
That's a kind of a long-term goal, but that's the goal.
that's true. Well
Hmm.
said. I look forward to that. That would be very big high point for us when that happens. So very good. All right. Any other comments about Opulent Voice? Any other updates or questions? All right. So then the next thing on the list is the AMSAT UK. It's called the Mode Dynamic Transponder. Successive interference cancellation. So AMSAT UK MDT SIC update. This is a really great opportunity for us to do some work with AMSAT UK and to be of service to the amateur satellite community. This also helps us because the receive channelizer filter is essentially the same design with parameterization differentiating them. So the AMSAT UK, this is a successive interference cancellation for digging out weak signals from 70 centimeter satellite band from the FunCube Plus satellite. So going up this year, then they're working very hard on this. So what we're doing is we're helping out with the MDT, prototype design. And over the past week, we have dug in and published a sort of a draft, the first draft of the polyphase filter bank that is looking down at the Earth and is listening for weak signal on 70 centimeters. What we did is to do this all in Python, and we have a Python notebook in the MDT repository that kind of shows you what this looks like. And this is a channelized 30 kilohertz set of spectrum where the different channels overlap. And they overlap perfectly to give you like a flat response over the 30 kilohertz. So some of the channels share some content with the next channel. And this is the way that this is described usually is that this sort of looks and feels like a spectrum analyzer. So, your spectrum analyzer, you go up and down, and there isn't like channels, discrete channels, like lumps that you would see in a communications channelizer. And this is the thing, the big difference between the AMSAT UK work and our High-Fourier channelizer is that we are a communications channel, and we do have like little guard bands. We separate out the uplink channels. So this work will help make a VHDL design for both cases. 64 channels of communication on the uplink for High-Fourier at 5 gigahertz, or 4 channels covering 30 kilohertz for 70 centimeter, so essentially like, the uplink for the AMSAT UK FunCube Plus. And so we did the model, and we've presented the model and shown some pretty pictures, and we now have a polyphase filter bank design that passed all 6 tests early this morning. And that's a really good big step. So in simulation, the VHDL design that's targeted for the ICE40 FPGA for AMSAT UK and the ZCU 102 for ORI for the High-Fourier, it worked. And the test summary is pretty terse, but we have a test bench to check where the coefficients, the filter coefficients for the prototype filter, whether they get moved into ROM correctly. So what we do is we generate the coefficients in Python. We then move it into the bit stream itself. So you run your Python, our Python notebook, generates a hex file. The hex file gets moved into memory. It becomes part of the VHDL, then it becomes part of the bit stream. So you don't need this file to actually run the code or anything like that. This is all done and calculated in advance for you. So that part passed. The delay lines, because if you can imagine a polyphase filter bank is like a card dealer, and they're going to deal out cards to, say, 4 people. Then they're going to start over. Okay, so you can see that this dealing, the cards over time, that you need to delay the presentation of the card to each person. That's what we're talking about when we say delay line. So that delay line worked correctly to distribute, 4 different filters to 4 different parts of the spectrum from the dealer. And that part worked. So fairly simple, but a lot of times you can get a weird wrapping error with this because, off by 1 errors. definitely a part of our lives. So that worked. And it parameterizes correctly. The multiply and accumulate, because once you deal out all your coefficients, now you have results, your IQs. Now you have your filter coefficients. Now you need to do a multiply accumulate. Now you need to present that data back. That all passed. The finite, so it's FIR filter, that's created by all of this. Okay, does that function correctly? So we're stepping back through the design, which each of the test benches, and they're all in the repository. The polyphase filter bank, which sets up the commutator, which is just going around and around, above and ordering this to happen, passes. And then there's an FFT involved. There's two FFTs. Instead of having a parameterized FFT, I'm not smart enough to do that. So like a dedicated FFT, so it's this one's 4, this one's 64, so 4 channels and 64 channels, and then just go ahead and set both up and do they get picked up correctly depending on which design you want, and that worked. So all of these, I think I misspoke. I think that's 7. Anyway, all of the tests are passing now, and the next step is to step back again, go all the way through, and check with Martin and David from AMSAT UK to say, okay, is this look okay? So we have that. Now we need to set up the this is now passed off in their design to general purpose processing. Really, that's where a lot of this will happen, because the FPGA in the ICE40 is relatively small. So all that stuff I've described is all the VHDL part for the FPGA. At this point, it now needs to start shipping the IQ samples, all this stuff, or not. Okay, so it's shipping the results, sorry, back to the general purpose processor, which is then we go through the channel and we identify the largest signal. We remove it. We go back through the next largest signal. And then we take those signals and we're going to then process those signals. So we work our way down and until we run out of time. So I don't really know how many signals we can process yet. I think back of envelope 4, at least 4. And so we'll just keep working on this and keep presenting it back to AMSAT UK, regardless of whether or not they're able to integrate this into the FunCube Plus. This is something that they're interested in doing. So future satellite, if this doesn't work, but we're trying very hard to make it available, working, and demonstrated terrestrially. So, like go out to 70 centimeters and look for weak signals is a good test. So that's the update for this week for that. It's on, everything is current, I believe, in our GitHub under the repository is called Mode Dynamic Transponder, and the Python notebook and all of the RTL, the simulation, and the synthesis is all set up. The test benches are all there, and there's a Teckle script because I use Vivado. So the Teckle script is kind of tuned for Vivado, but in the README file in the simulation folder is how to use this if you use something a little more open source friendly, or if you use GHDL. So I took a stab at trying to make sure that it was useful in that realm. We do not have any of the STM code yet. All I know is in theory what needs to happen over there. And I don't really have anybody identified to take that on or to kind of push that forward as fast. So I'm looking for help there, and I'm hoping that Martin will be able to do that part. So yeah, as soon as I hear back from Martin about all of this, make sure that he knows about the update, and that him and David and the other folks on FunCube Plus will have an opportunity to weigh in and review it. So they have all of the code in front of them and the links and everything. So that's the report for our AMSAT UK work. All right, any questions about that?
Yeah, are the signals being removed from within the full passband of the transponder?
No, this is 30 kilohertz that was identified by Martin as like, this is the weak signal area that we look at. The full passband,
Okay.
I think, is 180 kilohertz wide for the transponder. And that was one of my questions, because I saw in the in the PowerPoint presentation from David that it's 180 kilohertz, but Martin had told me 30. So I wanted to know, are we responsible for the entire thing? And the answer was no, just focus on the weak signal part. But the good news is that it's, since our design is just, you just parameterize it up, so you can change it. We can change it if we need to, if later on they go, oh, by the way, we needed you to do the whole passband. But the answer back was no, it was just this 30 kilohertz that Martin had identified.
I'm just curious if this would have any application for removing RFI in some given frequency band.
Yeah, successive.
Limited, obviously. Yeah.
So I would say in general, yes, successive interference cancellation is when you hear it described is like, oh, you have a spectrum. Let's say you have a loud, RFI interfering signal, and what you do is you're going to scan through and you're going to find out where the energy is. Oh, wow, these were, wow, that's really loud. Let's just delete those. And then you go back and you pretend like it never existed. So there's some downsides to this, but when you hear successive interference cancellation, that's what it is. You take your bandwidth, all of your different, essentially your samples, your data that you get by receiving, and you go back through over and over again and you remove high, interfering whatevers, whatever you don't want to hear or whatever you want to hear, process, and then remove, and then go back and start over. And that's the successive and the interference can't. So for RFI, yeah, it's not just for signals that you want. It's for, if you have loud interferers, that's one of the very common techniques on how to get it out of there. Now, when you delete it, you lose, everything's zeroed out for that little blotch. So if there was something underneath there, it's not going to reveal it. So there isn't anything that will magically, restore a signal that has been jammed, for instance, using SIC that I know of. That's easy, but you now have a fresh sort of like, you go back over and you check it again. So that's kind of what we're trying to do for them, is to provide this way of, receiving a number of signals in the 30 kilohertz in the time available, between when you have to throw all those samples out and start over.
So even if that signal actively disappears, when you go back through that particular spot, it's still blanking it out. It doesn't say, oh, it's gone, so I can open that up again.
As long as you're working with, it's sort of like if you go out and you're going to fetch something, and then you're going to work with that batch, and then you're done with that batch of work. Then okay, I'm done with that, and then you go and you pull another fresh batch. So in between the times that you took a snapshot of the 30 kilohertz, if that signal goes away, well, you're still working with, the presence or absence of that signal in the batch that you're working with. But, this is happening pretty quick. So signals coming and going, it would either be there or not. Usually interfering signals hang around for quite a while, especially if they're an intentional jammer. So that's, it's not too stale. You're going to be working with and eliminating signals and then sending that, to the operator or to the receiving stations. But these updates are happening fast enough to where you're not going to miss anything.
Are you talking milliseconds or?
Yeah.
Less. Okay.
Yeah, pretty quick. Don't know how quick yet, because there's always things that you don't know. And I'm somewhat familiar with the ICE40, but not as familiar as I am with Zinc. Or Xilinx parts or Spartan parts. So there could be things that I don't know yet. There undoubtedly will be. And I've got a couple of folks helping out here. So shout out to the folks that are helping with this project, and a big thank you to AMSAT UK for partnering up with us on this. This is a really good thing to describe cleanly and clearly, because a lot of interference cancellation is not terribly well documented, and there's very few examples of it in open source. So this is an opportunity for us to kind of provide at least one good reference for successive interference cancellation, which is very common in cellular. So this is happening all the time around you, and if you have a cell phone, you're using this a lot. This is how it's done. So it's good to learn. It's one of those things that we should know more about. Is that did it fully answer your question?
Yeah, pretty much. And I'm only curious as to about signals that you intend to actually be the ones that you're interested in. So you don't want to eliminate those. What IDs
Yeah.
then?
What I should probably say eliminate is that's after, like, you identify, you go from the strongest to the weakest signal. So in the case, I should probably say process rather than eliminate. What you do is you identify that signal and then, nab it. And we're assuming that they're going to be some sort of amateur signal. And
Right.
that's kind of the outstanding questions back to them is like, exactly what are you looking for? Everything, all of the content in that's above a certain threshold, so that's the ongoing question and answer. But once you have captured it correctly and then handed it off to the next stage of the pipeline, then you will remove it. And then you go back and look for the next largest signal. So when I say eliminate, it doesn't mean that you didn't pay any attention to it. It might be a contact or something interesting, or it might just be noise. So I think you're right. The term eliminate is a little too strong. It's process. You process that signal. Now we start again. This would be sort of like if you're driving along, and it'd be really nice to, okay, I see that there's a car in front of me. Can I just make it invisible? Oh, look, another car in front of me. Make that one invisible. Oh, look, another one further down the road. I can now see how far the traffic in front of me is. And then, oh, now I got to start over. I've driven 10 feet more. I need another fresh batch of potential people veering in my lane, to watch out for things in turns or potholes or whatever. So it's sort of like that. You want to process the signal, and whether or not it's an actual signal that you care about, or if it's just a natural signal or a man-made interference, doesn't matter. You're still going to process it further down the pipeline.
I was just curious if signals that you wanted to actually not process, if they had some kind of flag that would identify them as, okay, don't process these, leave these there.
Oh yeah.
And
Okay.
Working on a digital basis, I guess you could implement something like that.
Yeah.
Right. And so if it's just like an RFI that doesn't have it, then oh yeah, this one's for processing out.
Yeah, there's a whole field that addresses this. So signal identification. So quick signal identification, and then that lets you know whether you should waste any time on that or keep looking. So from an amateur weak signal point of view, there may be certain things that you want, and if you can identify them quickly, with the modulation index is this, the bandwidth is this, can I do some quick tests to determine whether or not that modulation type or bit rate or whatever is what I'm looking for, then I can prioritize that, and then anything else just gets dumped. So I save the processing time, which means that I can handle more signals per batch of spectrum. So the answer is a enthusiastic yes, that exists. It's just a small matter of programming to get it done.
Too bad it wouldn't work with analog type signals. I was thinking in terms of RA, where you're looking at that weak signal and want to take out the interfering adjacent RFI.
Well,
but these are all analog signals pretty much. I guess if it's not an intentional digital signal that you can encode with some kind of identifier that says, "Oh, I'm keep this."
Right. Yeah. Since we're on the other side of a pretty, we're on the other side of the ADC. So everything that we're dealing with is a digital representation, but it doesn't really matter if it started out analog or digital. We can still identify it and figure out if we want to spend time on it, if we want to make sure that the receiving operator can see it or not. Yeah, that's done. So you're totally on the right track. And this is really, this is all stuff that exists, and people have been working on it for decades. And at least the, you know, open source SDR folks, there's some of this out there, but you know, the things that you're
Mostly it's
talking about,
proprietary, I guess.
kind of, yeah, it's like not really, not as widely studied, appreciated, or mastered as it could be. But then we've got a good opportunity here, you know, when it starts to work, then, you know, and we can prove, like, say, okay, how much time do we really have using the ICE40 and an STM? How much time do you really have with 30 kilohertz, which is very modest. That's achievable.
Yeah.
And back of envelope, we can dig through and get some successive interference cancellation going on and show like how it works. So we can see what the limits are and to start, you know, doing things like you're talking about, like, oh, okay, let's prioritize certain types of signals. You know, we don't care about, you know, interference or, you know, we don't care about RFI. We want to actually hear the signals. So, you know, that's what's within reach here. And again, it's just an opportunity that we really owe AMSAT UK some big thanks for kind of inviting us and including us and saying, you know, reaching out, asking for help with this to get it up and running. So it's I think it'll turn out good.
Excuse me. So this would all be implemented in the actual satellite to say clean up the downlink signal that's going down.
Well, it's looking down and listening for signals in 70 centimeters, and then my assumption is that it's then transmitted, then it's presented back to somebody listening.
Right.
So like they're like, oh, this is what you can pick up from the satellite. Look at all these things that I wouldn't otherwise be able to hear, and presumably would they be able to try to contact them? And that's just my speculation on how they want this to be integrated. Because what we're focusing on is the receiving side, receiving from the Earth. So this is essentially an Earth observation challenge that we're talking about. That's our part. And you know, once it's in the processor, then it can be retransmitted. And you know, that part I know a lot less about. So it'd be really good to be able to get to the point where that was the short end of the stick. That was or sorry, not the short end of the stick. That would be the thing that was that we needed to help them out with. That would show that it was really quite far along. Yeah, so that's my report from what I know. We've picked up a couple of new people that are not hams yet that have kind of chipped in and been interested and contributed. And so I've encouraged everybody to really strongly consider getting the amateur license. Being able to educate people that we have a whole satellite service in amateur radio is always a thrill, because that even amongst people that are pretty serious terrestrial hams don't really know that. So that's happened a couple of times over the past couple of weeks. So hope to continue doing that.
It'd be nice if we could get a geo over North America.
Well, that's why we're doing what we do, is to try to get that to happen. So one of the next things on the list is the ESA, the European Space Agency, FutureGEO. Those presentations will be held. I got news over the past week that the ESA would like to hear presentations and would like a vote, or they would like to gather impressions. So I heard both of these things: a vote, which means one thing, and gathering impressions, which means another. But that is expected at Friedrichshafen in June 2026. It's called Ham Radio 2026. So we call it Friedrichshafen. It's a really large amateur radio event in Europe. And so we have to decide like how many people to send and what to do, whether to get a booth at Friedrichshafen, or we do have an offer from AMSAT DL to take up some space at their exhibit. They have a large exhibit, and that may be what we go ahead and do, rather than trying to field an entire booth in an international trip. And it's coming up really quickly. My expectation was that when they said 2026 for prototypes, that it would be at the end of 2026. that you would then make your presentation and have prototyping done. And, you know, in the back and forth with Peter Goltzow from AMSAT DL, it's this particular proposal is essentially a paper proposal, or we would say like a PowerPoint presentation about the design. So I hear voting in 2026 in June at Friedrichshafen, and I think that's when we're supposed to be done. Not really, no. That's when we're supposed to have our written sort of design presentation. So it was not, I was a little concerned at first, but it looks like, you know, but if we took a prototype with us and showed what we have, which is a lot of stuff working over the air and a lot of stuff done and published, and a very clear sort of path into the future of having a full system working, I think that we would be giving a very large amount of design effort, and we would be showing up with a big bunch of work in June. So that's what we have to kind of decide. So of you know, asked our board of directors, you know, like, what do you think? And written out a potential, you know, sort of a campaign plan at Friedrichshafen, and decide how much stuff to bring and how many people to send, and it will cost some money, and I think we can afford it. So that's what's in our near future. A lot nearer than I thought for this sort of demonstration. We will also demonstrate all of this at DEF CON in Las Vegas in August. And there's always something in the autumn that we try to show, like in October timeframe. Maybe PacificCon's a good place. I don't know. Looking for any sort of place where we can really show and demonstrate and present work. So that's kind of that was a big revelation to me that they had picked Friedrichshafen in June for presentations where there would be voting or some sort of decision, and then after that, I get the impression that the choice, or that the number of proposals for a GEO spacecraft from the ESA would narrow. So I think we need to be there, or at least have somebody there that will present on our behalf. And we're actively talking about that and trying to figure it out, because, you know, June will come up right away. We need to start making travel plans now.
So are they kind of talking kind of the same thing as the QA, where the ham gear is riding along with a commercial platform?
That is a really good question. It's not that specific. The ESA wants the amateur community to step up and show them what we can do. And so we took it very seriously. ORI is a participant in the FutureGEO program. We participated in the workshop in September at AMSAT DL Symposium. We are on the forum for FutureGEO. We've shared everything we've done, and we are hearing about Friedrichshafen being the place to go to present. So all of this is great, but this is all about proposals and designs, and it's all on paper. And the ESA representatives have made it clear that they are going to pick a proposed design and then go to commercial spacecraft people. That the odds of us building our own spacecraft and then getting it launched, like used to happen, very low.
Yeah.
And that this will definitely be something like QO100, where it is a custom built by a commercial company for an amateur band, like QO100 is. It's
Right.
most of that's custom built for AMSAT DL, with some of it being off the shelf, ordinary, you know, DVB-S2 back end stuff. And that's what they're telling us, that, and they've been very clear about this, but there is no launch scheduled. We don't know anything about any potential hardware, but it will undoubtedly be, my call would be, it's going to be like a QO100 situation, where they're just going to take our spec and then say, okay, you know, this is the proposal. Okay, well, we'll then look around and go, okay, what fits, and what relationships can the ESA leverage to get this in orbit? And then hopefully everything that we would propose and have done would then be ported or reflected or built for space. And that's probably the best possible outcome. Another potential outcome is that we spend a lot of time and effort into documenting this, and it goes into a paper report, a PowerPoint presentation, lots of details. Here's our repo, here's all our source code, and they shelve it and say, thank you, that's great. We now see where the amateur community is circa June 2026. And then sometime in the future, maybe we'll get back to it. So that could be an outcome from this event as well. There is a budget for this. The ESA set aside 200,000 euros for this. So they did say in September of 2025 at the workshop that they were intended to reimburse people for prototype costs. They won't reimburse for travel, which is understandable, but for prototyping, and that's a big deal. That's a very positive thing. And they did say that they would spearhead talks with spacecraft suppliers and builders, and that's a big deal. So that's why we take it seriously and why we're sharing and making sure that we're included in all this. It's stuff that we would do anyway because we believe in the design and just across the board. But the FutureGEO allows us to kind of like take our design and say, hey, this is right up. This is right. This is like what you're talking about wanting from the community. Here you go. And that's what we'll continue to keep doing. It was just a little earlier than I expected. So, June being halfway through the year, I was sort of expecting this sort of meeting to happen later in 2026. I think that was to me, that was a surprise. Yeah, we'll see how it goes. And then the last thing that I have is the work on Artemis II tracking. And I have a photograph of Loretta's dish, and I want to show it to you because it's really neat looking. And this is one of the 34 stations that were picked for the Artemis II tracking effort. And here it is. So this is her up in the high desert. This is like she calls it the camp up in the high desert in California. And this was originally a UHF dish. It's a 10-foot diameter dish, and it was a barbecue style dish, as you can see. And what she did, because she wanted to tune it up for higher frequency, 2.2 gigahertz for Artemis II or 2.4 in that range, is went and got a very fine mesh, which you can sort of see. You can see it's not transparent through the dish anymore. So a very fine mesh, well below the hole size required in order to catch those signals. And she put, this is like the first draft, put it all down and attached it. And what she's done is gone through and smoothed it out very carefully, because for these frequencies, you need it to be very regular surface of the dish, because that directly affects your system noise temperature and your signal noise ratio and your ability to recover. But as near as we can tell, given all of the equipment that she has, there's a really good rotor, really good LNA, very good radio, and everything is going to be at the feed point, including like the bias T and all that. So minimizing all of those distances, she's well within link budget for tracking the carrier signal from Artemis II. So I worked with her on the link budget to confirm everything and just to reiterate like what the pain points are. So yeah, so far she's in good shape. The long pole for her is the software side. So she's learning a lot of software tools. She's already got the dish pointing tracking thing that appears to be working. She went with PST rotator class of software for that. And she's gone back and forth on a couple of different other software platforms for actually like getting the signal, processing the signal, and handling that. So the delay, this launch was delayed. The delay did her a lot of good because she was able to kind of like, instead of just clapping it all together and hoping, she now has a lot more going on. So that'll be, I think it's going to work. So I'm cautiously optimistic. It's on the small side. A lot of the other dishes are huge. that are doing this work.
Yeah.
And have known good, pointing tracking programs. And this is like up and running in relatively short order. But a lot of the 34 stations out there are like this. I think she's one of the few individual stations out there. A lot of them are organizations or clubs or existing these sort of amateur astronomy sites. But this is coming together, and looking at the link budget, it'll work.
I like her feed.
Yeah. Yeah, it's
Looks
neat.
familiar.
Yes, yeah. She's a member of San Bernardino Microwave Society, and we have a lot of friends there, and are either currently members or Paul and I currently members or not. Usually currently. Sometimes we drive up there for the meetings. So anyway, that's the report on Artemis 2, and I know that so Rick had another meeting, but he is also directly responsible for helping DSES, the Deep Space Exploration Society, and their large dish in Colorado to get up and running for this. He's done an awful lot of work on the accurate time and frequency measurement, and have had very exciting work done for their feed for this, and figuring out all sorts of interesting things about their dish too. So really neat opportunity from NASA to include sort of distributed receive stations for tracking the Doppler. All right, yeah. See you, Aaron. Thank you so much for coming and all of the good news that you shared. I think we're done. So if anybody has any open discussion items or any office hour issues, complaints, to things they need, the floor is yours.
I have a question for Paul. So what are you programming for the power block? What are you programming the low pass filters?
I have to look it up.
Okay. So my concern if the alphas were too small or if they were zero, then that could cause what we're seeing with the no power readback.
Really?
So there's
No
two
problem.
low pass filters, exponential moving average filters in the power block, and so those filters need the alpha set appropriately for the filter to work, or for the power detector to work properly.
I think I'm leaving that up to IIO. I'm not doing anything directly to those filters.
Okay, so I mean that maybe it could just be a configuration issue. I'm suggesting. So I'll drop in a Slack as well, but just this is what's in the simulation right now. They're just both being, so I put them in the chat window. They're just both being set to 64 in the simulation, which is probably a reasonable initial value.
Are these your registers or?
Yeah, these are registers in
Okay,
the
misunderstood. Michelle, do you know what we're doing with those registers?
Which
Those
ones?
are these ones that are mentioned in chat, the low pass EMA alpha 1 and alpha 2.
No. No, I don't think I've done anything with it. I don't think no.
Yeah, so that's what I was kind of suspecting. Maybe they just weren't configured and they're zero, and so then we're not actually computing any power metric, possibly.
Yeah, I've stayed
don't
out
have
of
a
the
default?
power metric stuff. Well, default is probably 0, because that's how we kind of do it when we init everything. It should be set to 0, but I don't do anything with those. That's not one that I did anything more than to test whether or not you could write to it successfully, and that's it.
Yeah, they default to 0.
Okay, well, tell me what you want me to set them to, and I'll set up.
Let's try 64 for both of them.
Okay. I will attempt to do that next time I'm doing testing.
Very good.
What
I
happens if
suspect that'll
there's
give us
0?
an improvement.
What happens if there's 0? Do they not work? Is it a flat response?
Well, I think so. It's an exponential moving average, so we'd be multiplying by 0, right?
Dear.
So we wouldn't be accumulating. I need to double check what the the exact equation is, but I mean, I would assume, just looking at the source code here. Yeah, so the alpha, so yeah, the data, yeah, so we're multiplying the input data by the alpha. So if the alpha is 0, yeah, we're not going to accumulate anything for the average.
Well, that would explain why it's coming up 0, I guess.
Yeah, yeah. I mean, I kept thinking the readback was problematic, but then, it didn't make sense because the readback's working in the simulation, so it makes more sense. It's a configuration issue.
Yeah, I didn't realize there's anything to configure for that, so sorry about that.
No worries. Yeah, so basically there's two exponential moving average filters cascaded in the design, and so that it smooths out and we get a good solid average of the input power.
Is that just for the power indicator?
Yes.
Okay.
We had one in the Costas loops before, but determined we don't really need it, so we just have the only place we have the EMAs right now are in the power detector.
Okay. And do we have a definition of what the units are of the output when it does output?
Yeah, I mean, it's just I squared plus Q squared. So from the I squared plus Q squared, we know the bit widths. You could compute like a DBFS fairly easily. So in software, you can take the square root of the output value and then do the ratio with the number of bits to get a dB full scale type of value. And then if you know what all the gains are through the signal chain, the analog signal chain, you could compute a dBm value from that too. Well, you could compute the dBm without it, but I mean, if you know what the gains are, then you could, do all the processing and then give a good estimate of what the input power is. There is a nice square root estimation that we could do, but I don't think there's a lot of value in it. Software ought to be able to do the square root fairly easily.
If we even need anything more than just a relative indication.
Yeah, this provides a good relative indication of the power.
Cool.
That's something that just gets set from Dialogus. That doesn't need a spin of the firmware, right?
Right.
Okay.
Currently doesn't get set from anywhere, but it'll have to be set from Dialogus. If it works, then it won't require any firmware changes. If it doesn't work, then we'll be back to square one.
Okay. Yeah, we should
Expect it will.
Yeah, I think probably multiplying things by 0 probably will. That'll show it.
You're right. I should have thought of this sooner because my experience is if it works in simulation, it should work in the hardware, and if it's not working in the hardware, it's almost always a software configuration issue.
Yeah, those are usually good guidelines. Yeah, another thing we have coming up is we get to be part of B-Sides San Diego. And it's been a long time since I've been to B-Sides San Diego. I've been to B-Sides Los Angeles, B-Sides Little Rock, or one, I think it was actually Fayetteville, Northwest Arkansas. But I haven't been to ours in San Diego in a while, and it's at San Diego State University and attracts over 700 people, and a lot of them are amateurs and lots of open source folks, and I'm really looking forward to it. And so we'll be helping organize RF Village, so we get to be village people again. It'll be so we're gonna bring our stuff and also show off things like Meshtastic. We'll bring RF bit bangers and answer questions about how you make signals work. Probably going to be some communication security questions. And I'm looking for more. There's a couple of other folks we're going to support. Maybe turns out that transmitter hunting is very popular. I've gotten a lot of questions about that. So I think we should probably bring some of the tape measure antennas that we have in stock. And if we can possibly set up a real simple transmitter, then maybe we can have, hand out the antennas and maybe get something going there. So fortunately, that's something that we've done before and can be clapped together fairly quick, and it's fun. People get to actually physically do something and track something down. So it's like a game. But I've gotten a lot of questions about that. I got a question about, like, well, can you do a satellite demo? And I'm like, not so sure inside of Montezuma Hall and San Diego State University. So maybe, anyway, that's April 4th, and that just one day. So like 10 to 5, with plenty of opportunity to hang out and party at the San Diego State University bowling alley. They have a whole bowling alley there, and that's where the after party is. So plenty of opportunity to come back with some good stories there. I'm not really surprised with the popularity of Meshtastic. I think we saw somebody with a Meshtastic node on their backpack at the Vintage Computer Fair, which was this past weekend. And Paul and I went to that. In fact, you're wearing the T-shirt from 2024 right now. Yeah. It's a good show, and it has, for a computer fair with no radio stuff, there's an awful lot of radio people there, because saw at least 2 people from San Bernardino Microwave Society, and lots of amateurs, and the fellow that we met that did a really good talk about using the UNIVAC to program it's the aircraft landing system, radar assisted landing system for carriers. So he talked about, like, how this is accomplished, and with the patch tape from the UNIVAC systems on board. And wow, it was a really good talk. And lots of sea stories, of course. But he turned out to be a ham, and did all sorts of satellite radio stuff, and really, really great to meet a new friend. And he also lives here in San Diego, so hopefully we'll get him over to the lab, and have yet another person to talk about all this stuff about. So it seems to be like the Vintage Computer Fair crowd is eclectic and includes a lot of amateur radio people, and a lot of DEF CON people. So there was a number of the DEF CON group that recognized us, and we ran into them. So it was really fun. Growing show too, just since 2024, which was the last time I went. I think it's more than doubled in size in terms of floor space. Lots of old computers.
Got a few of those lying around. I actually have, I don't know if it's functional or not, but I have an old TI portable, the big sewing machine looking thing that,
Oh, yeah, luggable.
yeah, it was a luggable. I actually have one of those.
Oh,
No
cool.
hard drive, everything's on the big 5 floppies.
Wow. Yeah, it would
I
fit
didn't
right
know TI
in.
made it.
Yeah. That's right. This is right up your alley. All the vintage computer folks, and the portables, or portables, you know, 40 pounds
Almost portable.
portable.
It actually needed some wheels on it. They should have put wheels on that case.
Yeah.
Oh
I
gosh,
know of what you speak. That's neat.
that goes way back. A few
Yeah.
486s probably lying around.
Yeah. But I think the thing that's like, I'm a little biased because my first real computer was a VIC 20, and I just kind of adopted
Oh,
the one that my dad bought because I think he had ambitions of doing computer programming, and so I pretty much took it over, and I got all my 11 and 12-year-old fingerprints all over it, and that really, that made a big difference to me. Just dug in, learned how to do it from the little spiral bound user guide, and Scholastic Book Club at my elementary school had, here, type this program in and then it will do this. books. Like there was a whole section of computer programming books from Scholastic Book Club. And there was a series that was mysteries. So each chapter would have, move you further along in this mystery, chapter book for kids. And each chapter ended with you typed in a program to get a clue that would help you solve the mystery. Like, basic substitution ciphers called QWERTY code, because the top row is QWERTY, and then the U and the I and the O and the P were CODE. And then you got a hint there. So QWERTY code was one of them. And it was just so cool. This seemed to me totally normal. And that got me pretty much knowing how to program computers the hard way, just doing all that stuff. But I've spent a lot of time trying to track down these very cheaply produced newsprint paper books. And I've got a few of them, but like not all of them at all were captured. This is essentially like Scholastic Book Club ephemera, from 1981, 1982, 1983. But I've seen now, like, especially recently, just over the past couple of years, a whole revival of the Commodore, like VIC-20 and 64, and to a lesser extent, like the 128, which I don't know if it ever really took off. But the VIC-20 was this massive hit of a computer. We had one. I now have two or three of them. They work, but there's like a revival where you can actually get a refurbished like VIC-20. And all the parts are new except for the processor. You have to go find some new old stock and yoink it in there. Or you can get an emulator. It's all running on a Raspberry Pi, and it acts very similar to a VIC-20. So this is, to me, I'm like delighted, right? Because I'm biased. This is my totally favorite computer. And I'm just like amazed. Like the plastics are new and not yellow and like they all smell a little weird, because they're pushing 40 years old now. So that was really clear from this past weekend that the sort of revival of nostalgia computing is coming back. And then when you actually try to sit down and type at a real VIC-20, there's certain keys that are just in the wrong place because the world changed and moved on. Decided we would remap the keyboard, and the control or whatever is going to be in a different place. So you have to kind of like slow down and remind yourself, or go into like a K Pro 2, which was another one of my early computers. And yeah, well, it's a CPM machine. Yeah, just a delight. It was just neat to see. So I don't know, over the next couple of years, I think a lot of these projects will probably go ahead and come out with these, full up, nice, brand new retro computers. It's remarkable. There's some that are not ever going to come back, that are lost. And then there's some like that, like Ada boxes and Hacker boxes have done. And I'll show you one of them. I'll be right back.
Paul, I wanted to ask you, have you made any progress on the last week you were talking about the debricking protocols you were trying to get for some of your SDRs oh wow.
Yeah, this is a reproduction, and it's much smaller than the real one called the Kenback, a 1-bit computer, and little switchy poos and LEDs, and it did not come with a case, but it's hacker boxes, it's all emulated, it's not, but here you go. These are now coming out in all of these subscription kits. There's pretty routine inclusion of things like this retro computing in all of these embedded and Arduinos and Raspberry Pis and ESP32s out the wazoo, which are all extremely powerful compared to the older computers. So anyway, this is an interesting shape, so the real one is about yay big, and it has a case, so I'm going to go ahead and make a case for it, because it didn't come with one. But one of these, an original one, was actually at the Vintage Computer Fair 2 years ago. And that's the first time I'd ever seen it, because it predates the whole VIC-20 era. It was before that. And, just as a kid banging away on a VIC-20, I didn't know anything about it until fairly recently. So anyway, yeah, Paul had some stories about the revival of the bricked I guess the, Encyclopedia Brown style, the case of the brick Libre SDR. So I'll turn it over to Encyclopedia Paul here.
Yeah, great. I loved those stories when I was a kid. Um, we made one breakthrough. Actually, Michelle told me what to do, and I did it, and it worked. This is a pretty
Very
common
good.
scenario. Um,
Yeah.
the the problem that I knew I had that didn't have a way around was restoring the environment variables into the Libre SDR. It's got, in addition to the regular Linux environment variables, which are in RAM and they're normal, there's a set of firmware environment variables that are stored
Uh,
in Flash, and they have to be accessed through special mechanisms and so forth. And they can not only contain values, they can also contain little scripts.
mm,
And a lot of the functionality of the many different ways there are to load firmware into the Libre SDR is implemented by those scripts. And the one I was having trouble with had its environment wiped somehow. It became corrupted. And
mm.
one of the updates decided, well, it's corrupted. It's not passing CRC. So I'm just going to wipe it and put in a default environment, which is like 5 lines of important stuff like baud rate. And none of the scripts or anything are in there. So I started, I knew the problem and I knew how to set an environment variable. There's a FW underscore setinv for setting a firmware variable. So I started typing them in, and that turned out to be pretty painful because you had to figure, especially when it came to the scripts, because you had to figure out how to, which things needed escaping as you typed them in, because some of the characters are special on the command line. So when you type them in, they get mangled. So what Michelle told me is, well, maybe that firmware setinv has a mechanism for accepting script input. And sure enough, it does. And I skipped a step in the long saga, which is that if you're stubborn and you're going to type this damn thing in, whether you like it or not, you get about 2/3 of the way through the longer scripts, and then it stops because it won't take that many characters on the command line. So luckily, that restriction is lifted when it's running the script. So all I had to do was find a copy of the environment the way it was supposed to be, which actually is a file generated in the build process called umv.txt, and turn it into the format that setinv needs, which is changing the first equal sign into a space, and then just dump the whole thing into firmware setinv, and it restores the whole environment. And uh, one thing that it doesn't say anything about, doesn't mention, is that it also sets the checksum when you do it that way. If you type them in one by one, it doesn't set the checksum, so there's still a corrupted firmware environment. But if you apparently, and the way it behaved is that if I dumped it in with the scripting, then it completely restored it. Yay! So now I've got a Libre SDR that has the right scripts in it, and some of the more normal procedures will work then to load new firmware. So they're
Great.
all, well, 5 of them are working right now. The sixth one is still in a special state because I set it up in the remote lab for Everest to work on his integration of our Pluto MSK into his overall environment, which is Ubuntu based rather than build root based. So nothing is stuck. Everything is unbricked that I can unbrick at the moment. I keep waving my hands here because 3 of them are right in front of me. I've been running them on the desktop here, and over there is one of the Spectrum analyzers. So they're nice and warm. If my hands get cold, I can just put my hands on them.
Yeah, and they're warm
Great.
because they don't monitor their own
Yeah,
temperature,
we
right? You
discovered this. Yeah,
found that when you
I
opened
forgot
it
to
up.
mention that whole procedure of uh,
Mm,
calibrating frequencies on these Libre SDRs because they seem to be off frequency pretty reliably when you first turn them on. And the Pluto has this problem too. They're all over the place. When you get a new Pluto, it could be high or low or whatever. But these Libre
yeah.
SDRs, they have an interesting characteristic. They're always low, and they're always way down near the bottom edge of their tolerance band.
Yeah, we
And
saw that when we were trying to talk to it with the software modem
yeah,
because
You
I
saw it
have
on the
to
spectrum analyzer.
tell the software modem where to look. And when we put the Libra SDR transmitting and the software modem is receiving, it's like whoop. And so I was like, wow, that's kind of a lot, because Paul's like, oh yeah, it'll be right on, 905.050. And that's what I put in, but that was not where it was. So we could see it like visibly off frequency. And it wasn't just that one, it was all of them that were very
Hmm.
consistently off in the
Yeah,
same.
they're about 16 parts per million low, which is a
Wow.
lot. It's
Yeah.
terrible. And especially terrible since I was told going into this that these Libre SDRs had many upgrades, including better oscillators. And in fact, they do. The Libre SDR has a voltage controlled, temperature compensated crystal oscillator component in it. Um, and there's a separate little chip in there that gives the processor, or maybe it's the fabric, I don't know, uh, a way to set the voltage going to the voltage controlled TCXO. And you'd think that it would then be temperature compensated. That there's one, this board is really pretty crowded, and it's very nicely laid out, obviously based on something that was done by real professionals. And there's one part that's not included. And what do you
Hmm.
get? What do you think that part is? It's the temperature sensor. And it's also the voltage rail monitor. It's an 8 input A to D converter, which actually has 9 inputs because there's one internal input that goes to the internal temperature sensor. So I'm thinking they couldn't get this part, or it was too expensive, and they just left it off. And the temperature compensation is doing its best to compensate for the temperature that's railed all the way to one side because the temperature sensor is missing. And so probably 16 parts per million is the range that it can compensate for, plus and minus, and it's nailed at one side. So maybe I can add that device to the board and it would just start working. Or maybe I just won't have temperature compensation, and it'll be uh, another crappy SDR with a crappy.
That's unbelievable. So it's
Oscillator.
not just like a simple thermistor or something.
No, I could give you the part number if you care. It's
That's fine.
like eight input A to D converter with temperature sensor from
I
some
see.
real like TI or somebody like that, somebody you've heard of. And it's a little tiny. I don't know the name of that package actually. It could be hand soldered with a little patience and a microscope. Um, if I had the parts are available. I can buy them from DigiKey anytime I want. They're uh, they're like $12 each, which
No,
would
that's
be a
not bad.
substantial amount of substantial fraction of the bill of materials price for the Libre SDR if they had to buy them at DigiKey prices.
No, that's probably why, is that maybe the part ended up being uncomfortably expensive with a long lead time at that particular time. So that just, it doesn't mean that it doesn't work. It just means you're responsible for knowing where it's going to put the signal.
Yeah.
Wow.
This-
Hmm.
well, I need to run a temperature cycle on these things and see if it's also temperature compensated. If it's temperature compensated internally and it's just the voltage control part that's missing, I'm okay with that. We can compensate for that in software. But if it really needs the closed loop temperature control, then might try to put in that chip or
Okay.
might not.
Well, we have more than one, so we can afford to experiment with one of them.
Yeah. Between the
But
ones
yeah,
that we bought
that was a
personally and the ones in the lab, we have six.
right.
So
Yeah. So yeah, that's anyway, that was a good spot on your part.
Yeah.
It was
Wow.
noticing that it was not just, because it's one thing to have them all kind of off, and they're all like, you know, but they all were really consistently off in the same way. So it drew some attention. Paul sat down with the schematic and went through it and then compared the board, so it's kind of a complicated looking board. And then, look, this one's not
Sure.
populated. And that, I think his assessment's right on. And, but yeah, so like we could talk about the difference between accuracy and precision. And then, a known offset is, we can deal with that, but he's right. Like going through a temperature cycle to make sure that, like, is it always over here? And if it is, then we just compensate. We just add that in, you know, and then there you go. We've got it somewhat fixed, you know.
Well, actually, it's already somewhat fixed at room temperature because they implemented the same calibration procedure that the Pluto did. The Pluto has a way for you to type in, it's one of those firmware environment variables, in fact, type in what the frequency of the local oscillator reference actually is. On the Pluto, it's supposed to be 40 megahertz. So if it's on frequency, you just type in 40,000,000, and it doesn't do any compensation. On the Libre SDR, it's not, maybe it's 40 megahertz. It's kind of hard to tell. There is a 40 megahertz oscillator in there. On the Pluto, if you don't read the documentation very carefully and ignore some of the documentation that's wrong, you might be under the impression that this frequency compensation is only for an external reference oscillator, which you have to turn on with another one of those firmware environment variables. The Pluto doesn't have a connector on the exterior of the box for an external reference oscillator, but it does have circuitry for one inside. The connector was not even populated on the first generation Plutos, but on the modern ones you buy today, there's actually one of those little horrible little snap-on RF connectors for the reference oscillator, and you can bring it out through the plastic case if you want to. And I've done that on two of the Plutos, so you can control them that way. But it turns out that frequency compensation value works for the internal oscillator as well. So they must have left that part of the code untouched, or maybe they had to do something extra to make it work with the circuitry they ended up with. I'm not entirely sure. I think it's basically worked by accident because they left it untouched. And you type in something near 40 megahertz and you get a compensation. So I went through, that's the reason the spectrum analyzer is on a desk here, because I was calibrating all the Libre SDRs by measuring where they're actually transmitting and then computing what the compensation would have to be for against 40 megahertz and then typing that into the firmware environment variable. So at room temperature, these guys are all within 10 or 20 hertz of on frequency for now. So we'll see what happens over time in temperature. Maybe.
Wow, that's interesting.
The one other little tidbit that's interesting about that exercise is that this spectrum analyzer is the one that was going to the other lab, the RI South lab, and we didn't get it quite as spec'd up as the one we have in the remote lab for here, the remote lab West. This one doesn't have the oscillator upgrade in particular, so it has like a half a ppm oscillator in it, maybe. But it does have an input for an external reference. And over there, behind the laptop, is my Flex Radio 6600M, which has a GPSDO in it, which has an output, a 10 megahertz output, which is like 10 to the minus 13th or something like that. And so I ran a little cable. I think it's this one, this cable here. It has 10 megahertz in it and runs over to the spectrum analyzer and gives an external reference with high precision. So I'm pretty confident that these, when I say these are on frequency, they're on the actual honest to God frequency. I can do the same thing in the remote lab. Of course, there's a GPS receiver in there with a dedicated GPS DO, with a display and everything. It was a project that Tapper put together years ago. They had a bulk buy of these GPS receivers and they made a little circuit board with a display and everything. And I got an actual outdoor antenna on that one. This one, all right, I got to show you this. See if I can get my external camera thing to work. Yeah, you should now be seeing the world through my iPhone. There you all are.
Wow.
Okay, so that, that's my GPS antenna. It's on a mic stand clamped to the wire rack. The reason it's up like that is if you put it down on the wire rack, but next to those bins, it doesn't work for crap because the bins are enough to interfere with the GPS reception.
Wow.
Yeah.
Looking at metal flashing and a a tile roof, which is practically a Faraday cage, but it works fine just for having been moved a foot off that shelf.
So okay, so the 10 megahertz is just for your spectrum analyzer, not to lock in the SDR, right?
Yes, that's
Okay,
correct.
yeah,
Uh,
yeah.
the Plutos that have the why are you not seeing me? Because I'm video's still muted.
Yeah.
Um,
Yeah.
the Plutos that do have the connector brought out could be run from this because they will take 10 megahertz in.
Oh, they will. Oh,
I think they will.
I've always wondered about
It
that
doesn't have
because
to be
I've got
40.
one of the original Plutos with nothing coming out of it, so I'd have to go into it and put in a connector or something because
You
that
know,
is a
which
pretty awful oscillator they had in the Pluto.
there's also there's a part that's pin compatible. You can just drop in that's a better oscillator. Um, I don't know the part number, but you could probably Google it up.
I
Somebody figured out how to modify the Pluto.
I thought I've looked for that and it was either discontinued or something. At least the one that I was looking at, because I was trying to do that, and there was somebody out in it was right in the middle of the COVID thing. So there was a guy in Germany where you couldn't mail anything anywhere to Europe or whatever, and he was actually setting a little board that could plug in there, and I could just never we could never figure out how he could get it from Germany to here, and then he just quit providing them, and so I just got left out of it, but. Yeah, the drift is pretty bad on the original Pluto. It's uh,
Yeah, you can watch it
well,
wander around. It's really terrible. It's
yeah.
good, fine for lab experiments, but if you're trying to make a radio out of it, it's not that great. I
I
think the
don't know
Libres
why
are
they.
definitely more stable.
Oh, yeah, I mean most newer SDRs have much better uh, TCXO, but oh well. Can't afford a new. I can't afford a new Pluto anyway. So well, I'm glad you got that fixed then. That's great. Good progress.
Yeah, me too. It was it was hanging fire for a couple of weeks there and getting in the way. So having more Libre SDRs helped with that. Like I was able to be a little more bold about making changes to the one that was wedged.
But
Nothing
true,
worse than
when you
breaking
only
your
have one
last
thing,
spare.
yeah, you treat it with you baby it to death. No, it's worked
Yeah.
out. I think the next
I've,
week will be good.
Cool.
I've worked out a system now since I have so many of these Libre SDRs. Each one has the IP addresses for the ports and who owns it. And I keep uh, attenuators on the transmit ports in case it transmits without being hooked up to something. They'll survive. These are not supposed to be transmitted into when they're open.
Hmm.
And I've got the calibration factor on a little label on the back.
Oh, wow.
So
Okay.
if that gets lost, I can take it off the label and type it back in. Ask
Wow.
me how I know that could happen.
Wow, that's really organized. Wow. Okay.
You know,
I
when you
can't
have a
imagine
label, everything seems like it needs to be labeled.
how can you keep up with all this? I can't understand. Oh wow.
You're
So
assuming
cool.
that I'm keeping up with it. I appreciate the vote of confidence.
Just being generous.
Wow.
That is amazing. Wow. Mm.
Awesome.
I still haven't done anything with this one though. This one needs some attention. This is another one of those Pluto clones. This one turns out to be
Mm.
a 7010, so it's not of any interest to us for current operations, but could use it for Maya or something like that.
Oh yeah. Is that the fishbowl? Fish sauce?
Yeah, this is
Okay.
the fish soup, well, I don't know, fish something. It's also
Fish sauce. There we go.
no, this one doesn't have anything. Thought it had some naming on the back, but the back's completely anonymous.
Huh. That looks like the fish scale. I'm just gonna make up a bunch of names for it.
That was the supplier.
It's
It's the
it's like
name of the
the name
product, I
of
think.
the project and
Oh, I see. Okay.
cool. Yeah, that was the one that Everest likes. He's enthusiastic. He likes the one that has the 7020 on it because they They do have one with the 7020, but he seemed to think it was easy to work with, and it's one of the ones in Suzuka that he orders around. Yeah.
This is much more compact. If you compare this to a Libre SDR, you can see that it's quite a bit smaller.
Oh yeah, yeah.
Yeah, it kind of is.
Like if you order it with a case, you get this 3D printed case.
It looks like it clamshells open. It hinges open.
I put wires in instead of the screws because the screws were trying to bite into the plastic and they weren't doing a very good job.
Oh,
So I wired it up with hookup wire.
okay, cool.
This wire is actually pulled out of 50 pair cable that came out of the ground on my college campus when I was in college. So I still haven't used it all up. We got like 50 feet of 50 pair. This is a lifetime supply of hookup wire. And it's just exactly the right kind of stuff to go into one of those wireless breadboards.
So
number
you're
22
saying that
okay.
we should advise college students to go dig up 50 pair.
Well, you know,
if it's still there.
This is the same college experience where my roommate got busted by the cops for stealing stuff from the phone company. So
okay.
Ooh.
He got in with some bad dudes, and they broke into the compound and broke into a service truck and stole a bunch of, butt sets and clip-on adapters and stuff. And it didn't take them long to catch them. I think they were waiting for him at the time.
Wow.
Very embarrassing.
Oh dear.
We're all involved.
Well,
sure.
Some people only learn things the hard way. Wow.
Luckily, I wasn't involved, although he did have some of the booty in the dorm room. He was a suite mate, not a roommate. So he was
okay.
the other side of a wall from me. So the cops didn't talk to me at all.
Did some of your stuff end up warm because it was next to stuff that was hot?
Not that I'm aware of. It'd be hard to tell sometimes.
Never a dull moment.
Oh my goodness. Being nefarious with the phone company. I had kind of a little of an experience, some nefarious activity with the phone company. And this is in high school when our high school brought in time sharing computers. They remember those. And so I was at the time sort of the graduated from Boy Scouts to the Explorers, and the local meeting was being held in a local AT&T building that had back the switching and all that for the local area, and so it had just a keypad to enter the building. So we knew that to get in the building, and they happened to have one of those old clunky, what is it, Model 33 teletypes that used to communicate over the phone line, so you could access the time sharing computer. And so a couple of us adventurous people that were trying to log into the timeshare after school hours would just go into the phone building and go into the room with the Model 33 and then just log on to the timesharing computer. Of course, the school then started getting extra charges for the extra time that was being used on the timesharing computer, and we sort of got semi caught for that. We were just kind of given a strict warning to just, okay, are you
supposed
they
to
didn't know
it was
where we were
illegal.
coming from. Yeah, they didn't know where we were accessing the Model 33 typewriter, so they just thought, is that like a business office or something? Then back then they couldn't actually track the actual phone. It was, even though it was on the actual phone building. So we just kind of dropped it and got away with it for a couple of months of getting extra time on the I think it was a GE something or another computer that was being used for the time sharing at the time. But anyway, that goes way back.
Yeah. You'd think you'd be able to find these Model 33s lying around at vintage computer festivals, but they're very hard to find now because they're big and heavy and dirty and they smell bad. And if you operate them, they're loud. So most of them have been scrapped long ago.
Oh yeah, yeah. I
Even
remember
by people who wanted to keep them.
Well, yeah. I remember they had an, what is it, an automatic, it was like a little tabbed cylinder that would run that would give the name of the typewriter. And so I
Yeah,
remember
the
that we had to
WRU responder. Something like that.
yeah, we had to dig into the teletype and pull that out before we would log on to the timeshare, so we could be identified. Just pull the little cylinder out, and then we got to put it back in, and
In the
close
days
it all
before
up, and
caller ID, you were anonymous.
yeah. So that was yeah. Anyway, your story about breaking into the TNT, I mean the phone truck, kind of brought those memories back.
Was on the lookout for terminals at the Vintage Computer Fair. Um, Pickings were very slim.
Hmm.
There's an Heathkit H19, which is a video display terminal of the
Yeah,
dumb variety, um, for $300. It was in pretty good shape, but that's kind of the going price for a usable terminal these days. And
the
the only other
CRT
terminal I
wasn't burnt
saw,
in.
say again?
The CRT wasn't burnt in.
No, no, it wasn't bad. Um, didn't have any noticeable burn in, and the keys weren't filthy or worn out or anything. Case wasn't banged up. Of course, one of the rules at the consignment table or consignment room for the spare is that you're not allowed to plug anything in and turn it on. So whether it worked or not, I can only say that it said it worked on a little piece of paper.
Yeah.
The only other terminal I saw there, which actually caught my eye and had me tempted for a few seconds, was um, a Diablo printer from Xerox. It was like an enormous typewriter, daisy wheel and
Yeah.
keyboard kind of terminal. And those are legit terminals for like CPM.
I had
Period
one
appropriate.
of those daisy wheel printers as well as an 820 CPM, 822 CPM machine.
Oh, there you go.
My first computer.
I skipped over the whole CPM era. I went straight from Commodores to IBM clones, but I've been filling in with my retro hobby. So I've got some CPM computers now, ranging from about this big on a credit card sized uh, circuit board up to legitimate old luggables. Like I have a Zorba that somebody dug up for me, which was one of the last new CPM models to come out. A little bit too late to be a valuable CPM model, already competing with IBM PCs at that time. And so they went out of business, and most of their inventory, a few thousand units, got surplused out for half price. And most of the ones that are floating around the used market are from that batch, I think. And they're basically new old stock. They've hardly been used at all, because even somebody who bought one, brought it into their office, it didn't take them long to figure out that what they should get is an IBM PC and put this one away.
Any old M-size and Altairs showing up at any of these shows?
A few old ones and lots of replicas.
Oh, replicas, yeah.
Some full-size replicas, and there's a pretty good category of like half-size replicas like that Zenbeck that Michelle showed, that are just an emulator inside a appropriate looking shell with, it's got to have all those switches and LEDs on it.
Yeah,
I've
you
got a
have
couple of those.
a PyDP, which is a PDP. It's real close to you right now. And there was a number of those, along with like actual PDPs sitting there. Probably the neatest one at the Vintage Computer Fair was uh like I don't know if it was a PDP, pure PDP or a clone or a similar one that was actually playing chess against you with a physical chessboard, sensors, and then it would play chess with you. And that was one of the interesting exhibits in there, but you have one that has like a little miniature one with a case. You should show. You should show.
I'm trying to activate my phone again, but apparently it's once per session.
You'll have to go bring it over like a plebe.
Well, but then it wouldn't be plugged in.
Oh,
They're running
okay.
over there, blinking their LEDs.
Yeah, it's like going to Harbor Freight. The old joke was the tools you get at least one use out of the tool from Harbor Freight. It's kind of
Yeah,
unfair. You should get several, but that's all you
yeah.
get. One use of your switching the camera to the. But yeah, you should
Oh
be able to
my.
Share it here, no problem. Oh
Oh,
yeah,
cool.
there's two of them. I forget. Yeah,
Wow.
yeah. I was thinking of the PDP 8, the Pi PDP or whatever.
Yeah,
So
the one on the left that is the Pi DP8. It's a Raspberry Pi with a half size or so PDP-8 front panel. The other one is a similar arrangement that's emulating an Altair 8800, I think.
complete with font, so those are pretty popular. There was some Altair components, like some actual,
Right. Okay.
ones that were there, but there at least as many of the little replica kits that you can get.
Here's this one wasn't plugged in anyway, so this is the Altair.
Yeah.
Yeah.
Yeah, so not as big and heavy as the one that used to
The
use.
kit runs on USB power.
Yeah.
Oh, wow.
Actually, that's for programming. The power goes into this little coaxial.
Ahead of its time.
Yeah,
Yeah, not bad.
got that
Neat.
satisfying click of some of these are like spring-loaded momentary toggles, just like
Oh,
the
boy.
real thing.
Just
Yeah,
like the real thing. Amazing.
it is. Like
Yeah.
like Paul taught me this. It's never too late to have a happy childhood. So you can get this stuff, that you either missed or want back. You can have it. It's
Let me show you
Get that old nostalgia back.
one other piece of treasure here. Little dusty. It's genuine dust.
Oh, S100. Oh my gosh.
It's not though. It's
Oh, it's not
uh,
S100? Oh,
this
okay.
is um, an RC 2014, which is named after the contest that it was created for. It was a build something for us and show us what you can do in 2014. And he built a predecessor to this. The back
Okay.
panel, I'll show you one of the cards. It's just
Ooh,
pin headers.
pins. Ah, wow. Okay.
So instead of a real slot, it has
Yeah.
just a bunch of female pin headers on it.
Okay.
Why he did it that way, I could not explain. But they're relatively cheap and they have a lot less insertion force to worry about. So this is a complete set. There's a Z80 board, and
Mm.
this was the compact flash board for just they put you way up into the high end of CPM. So you've got a little hard disk there. Serial port board. This is I/O. You can light up these LEDs one by one. You can also there's also pins you can read on that board. And then on the end is the cheater. For a terminal emulator, this is what I
Raspberry.
use for the serial port. It's a Raspberry Pi Zero. Um, so you log on to this and then terminal to the serial port, which runs on the bus. This is a lot of fun put together. And I made the little wooden base.
Oh, okay.
It's one of my 6 things on Thingiverse, by the way.
very
The,
good.
did you hear that Thingiverse has
Wow.
been bought up? That's the big news with Thingiverse. They belong to a separate company that also makes upload your design site and will make little miniatures for you on their 3D printers.
So I guess we'll be looking at Arduinos in 10 years and reminisce.
Quite possibly, you know.
Well,
Now that
reminisce about
Qualcomm
that
has this.
time in late 2025 when Qualcomm ruined everything by buying up Arduino.
Yeah, it's unbelievable that, well, I guess somebody wanted to cash in on it and can't blame them.
Something.
Maybe,
We
or maybe they
I
just bought the hype.
I guess yeah, it doesn't make a lot of sense to me. I'm I don't I don't know. As a
Well,
ex,
I've heard
I used to work at Qualcomm, and I'm like, so,
why.
yeah, why does this? Who? Yeah, I haven't figured it out yet. I'm sure somebody had a good business case for this, or I'm a little baffled.
It's not the first time they've tried to put a foot in the pond with the open source maker people.
Yeah,
it failed the first time. I don't know why they thought it would work any better this time.
I don't know. I guess we'll see. But
Well, I've heard horror stories of people maybe pulling out their libraries out of
yeah,
Axis and so forth because they're afraid that something about the rights that were being written out of open source and now being said, oh, well, it's really actually proprietary or something, and people just trying to pull libraries and things out of the repositories. But anyway,
yeah.
Well,
kind of sad.
if they had a generous open source license in the first place, there's nothing they can do legally. And if they didn't, then they're not really part of they had no standing to rebel against the commercialization. So.
Hmm.
But fear has a hysteresis curve. So, you can destroy an awful lot of goodwill by scaring people or by doing something unexpected or not immediately, like not reassuring people right off the bat. And so far, what we can tell, like there's a hack fest coming up at UCSD called Data Hacks, and one of the platforms that they are kind of like inviting the students and participants to use is this Qualcomm, Arduino,
Sponsored by Qualcomm.
because it's sponsored by Qualcomm, and and the experience so far from previous little hack fests that and other events, similar events, has been that most of the participants spent a lot of time trying to get it up and running, that it was very difficult to get up and running, that it was kind of a hog, that they didn't actually get to the hacking part. And the sort of that goes against the grain of Arduino, which was easy to get up and
Yeah,
running, to be able to get
yeah.
to cool things to do with it quickly. And this is not that. So I haven't fixed it yet, and that's a bad way to start out. So that's the feedback that I got from the organizers of Data Hacks, is that they know that issue, and that and
They had
Paul,
to
you
go out
have
of their
this,
way to
right?
make it bad.
You've got this Qualcomm Arduino.
I bought
I think
one. Yeah, I bought two,
yeah,
in fact, because I always buy two of these things so I can have them talk to each other or whatever.
yeah. As I think you mentioned it a week or so back that this was your experience as well, that it was not really
Hmm.
pleasant. Like you can't save. That was the first weird thing, is you can't save your script. You know,
What?
no way to save it. No save as, no save. And that was the first thing that you hit. You were like,
Yeah, it's pretty obvious they rushed it out to meet that trade show deadline. Um, the board is fine. There's nothing horrible about the board, except it's kind of a dumb idea. Um,
I think that's a
uh,
problem.
the reason user experience is so bad is that the software they provide is terrible. They work with the old Arduino software. If you want to work with that, you can, but that's not what they push you toward. They're pushing you toward this their new Arduino Lab, which has a lot of support for the fancy stuff. See you, Matthew. Um, they've got stuff that's for AI in the main Linux side of the processor, and then the Arduino is sort of tacked onto that. And they call it an Arduino because they could get the name, but it's not really an Arduino with an AI coprocessor. It's a Linux machine with AI stuff in it. And oh yes, there's an Arduino tacked on the side. There are lots of people who've been making stuff like that for a long time. And yeah, in fact, I've got one right over there. Um, it's a little PC with a Arduino that's built into it. And the appropriate reaction is so what? But this half-baked Arduino lab thing that they provide is where half the delay comes from. So it takes like 25 seconds to boot Linux on this,
Gee.
and then you're able to start booting the Arduino lab, which takes another 25 seconds. So the power on experience is pretty poor.
Mm.
They do say right up front that they recommend the larger memory version if you're going to run standalone. In other words, running Linux on the device. And that would be perfectly fine, except that they weren't delivering, and I don't think they still are delivering the one with more memory. The ones that came out first was the one with less memory. And it's really underpowered for running Linux.
Kind of a
Well, I guess
disappointment.
raspberries are next.
Oh, I hope not, but yeah. I
Raspberries
mean,
were Raspberries were born subverted, right? They're
Yeah,
they're
kind of.
Broadcom, right?
That's true.
It doesn't say Broadcom on the outside, and the Raspberry Pi has a foundation and a company and stuff, but really it's a Broadcom development board, and
True.
that's fine. They've done a good job of hiding it, and they've done a really good job of providing usable configurations. Of course, right now they're hurting because they got to charge extra for the memory because they use relatively
Mm.
modern memory that's
Oh,
hooked up by the AI guys.
oh, memory is ridiculous. I mean, have you priced SSDs lately? My gosh. Ugh.
Not very late, not very lately.
Well, I have to because I wanted to replace the SSD cards on a laptop there. I wanted to upgrade to SSDs that have the built-in buffer rather than using the computer memory for buffering. And I was able to get a pretty good deal on a WD Black 850 or something about last August for like, oh no, it's only like about $160 or something. And now the same SSD is running for over 300,
Wow.
close to four. And this is one with a nice heat sink and everything for the SSD. But anyway,
Yeah, we live in interesting times, that's for sure.
We got a
great.
bunch of those NVMe SSDs as part of the remote lab. We probably, we're writing them down for tax purposes, but they're actually getting more valuable because the price of memory is going up.
Truly.
Weird, weird thing that I never anticipated. All right, I'm gonna have to get going.
Yep.
Okie dokie.
And
Okay, till next time then.
yeah, no, this is exciting.
Fantastic, guys.
Yeah,
Thank you.
I think we're gonna have a good week and hopefully tons to report next week. And yeah, wow. Wow. It's just a great
I
week.
kind of like to hear more about the your friend out at the high desert with the Artemis stuff. Really interested in that.
Okay,
Really
yeah,
like to see more about that.
sure thing. No, we got a lot written up between us, so maybe I'll just put it in the newsletter, which still needs to go out. I keep adding to it, and gotta get it off my desk, and then start all over again for the next issue. So yeah,
Great.
I'll include the link budget and the photos and the Odyssey because it's a very compelling and good stuff. And she's had a lot of success with the contesting over the past year and just contacts for like roving operations and things like that. So it's coming right along. So yeah, I'll definitely fill that in a bit more.
Great.
Awesome.
Okay.
Okay, I'm going to sign off here and get some food
Bye-bye.
and do all my chores. So yeah, see you
That's
soon.
me.